Part 2 contains 4 sections. Okay, now they all focus on the security critical topics here. We will start first with the cloud security consideration. We're going to talk about vulnerabilities, provider evaluation, on-premises controls, and data sovereignty. Now, let's start with the vulnerabilities related to the cloud. Now, the first one is about authentication attacks and cloud authentication, of course, systems. Now, both of these are frequently targeted through cross-site scripting, cross-site request forgery, credential stuffing, and session hijacking. Now, because cloud services are accessible from any location, the authentication layer becomes the primary defense boundary. Implementing multi-factor authentication, certificate-based device authentication, conditional access policies, and continuous session validation are essential countermeasures. Now, there are many different type of federation protocols like SAML and O authentication. Now, for denial of service, cloud environments face both traditional DDoS attacks and application layer attacks aimed at exhausting compute resources. There are so many tools, by the way, out there. The easiest and the simplest one to use it is the LOIC, which stands for Low Orbit Ion Cannon. It makes basic denial of service attacks accessible to unsophisticated attackers, while botnet for higher services enable large-scale attacks. In cloud environment, the DDoS can also trigger auto-scaling mechanism that inflate cost even when the service remain available. Cloud providers offer DDoS mitigation services like AWS Shield, Cloudflare, and others. But these must be properly configured and budgeted. Now, the other one is data aggregation and isolation. In the multi-tenant cloud environments, the coexistence of data from a different organization on shared infrastructure raises questions about data isolation, cross-tenant access, and provider data handling practices. Organization must verify through contracts that the provider cannot aggregate customer data for resale, that logical isolation mechanisms are in place and audited, and that the co-tenancy risks are mitigated through proper hypervisor hardening and network segmentation. Now, for data remnants, now when cloud infrastructure is decommissioned, retired, or reallocated, residual data on the storage media represent a significant confidentiality risk. Standard formatting operations do not securely erase data. They merely remove file system pointers while leaving the actual data recoverable. Secure media sanitization requires either cryptographic, erasure completely, where the encryption key is destroyed. That's what it's meant. Multi-pass overwriting, using tools like HYOK, or physical destruction. Organization must, require the provider through contracts to verify that their cloud provider implements certified media sanitization procedure. Now, for misconfiguration, this is the leading cause of cloud breaches. The AWS Cloud Trail monitor API activity and configuration changes, while services, like AWS Cloud, other, type of cloud services run automated rules against infrastructure configuration. Now, the last one here, we have the customer error. General errors include IT teams lacking cloud-specific security training, rapid migration driven by business pressure rather than security readiness, and the failure to implement the shared responsibility model. Many organizations incorrectly assume that the cloud provider handles all security, when in reality, the customer remains responsible for data classification, access control, application security, and configuration management. Now, given these vulnerabilities, organization must conduct a thorough due diligence before entrusting critical assets to a cloud provider. Let's take a look at the evaluation framework here. The first one, we have regulatory compliance. You know, does data fall under ISO 27002, ITIL, COBIT, HIPAA, and others? Other industry-specific requirement? Will the provider undergo certification, accreditation, and review? Well, now, you could see here, there are different jurisdictions impose different requirements here. Each one of them has a specific purpose here. Like, for example, the HIPAA for healthcare, the GDPR for European Union data protection, and like a PCI DSS for payment card data. Now, access and authentication. Who manages data access? What contracts apply to individuals with logical or physical access? Are insiders a risk? What authentication mechanisms are enforced? Well, you can see that cloud computing fundamentally changes the access control model by placing data outside the organization's physical perimeter. Both outsiders accessing the cloud through the internet and insiders at the provider who have logical or physical access to infrastructure represent potential threat vector. A security professional must evaluate what authentication mechanisms are enforced, such as certificate-based, biometric, MFA, multi-factor authentication, how privilege access is managed, and what background check and access review procedures the provider maintains for their employees. Data classification. Now, how does the provider classify data? What encryption they're using? What type? Is used for data at rest and in transit. How are encryption keys stored? Is virtual private storage available? Now, you could see understanding how the provider classifies and segregate data is extremely important. Encryption specific matter, like for example, like AES 256 provide the best and much stronger protection than AES 128. Now, whether encryption is applied to data at rest or data in transit or both must be verified. Key storage is equally critical. If encryption keys are stored alongside encrypted data, the encryption provides limited practical protection. Virtual private storage, which provides transparent encryption within a screened subnet (DMZ), offers an additional layer of protection for sensitive data. Now, employee training. Ask. People remain the weakest link, of course. How does the provider train their employees on security practices, incident handling, and data protection? Now, the second thing here, we have the SLA terms. Now, this is important. SLA terms and right to audit. The SLA is the contractual foundation of the cloud relationship, defining uptime commitments, performance benchmarks, support response times, and remediation procedures. The right to audit part, which must be agreed to in writing, gives the organization the ability to verify security claims through site visits, configuration reviews, and access control assessment. For regulated industries, the absence of audit rights is a disqualifying factor. I mean, in no time. Now, the long-term viability is the provider. Sorry, if the provider fails, what happens to your data? What are the provisioning costs? What format is the data returned in? Track record and financial stability matter in this case here. Now, the last one, incident response and business continuity and disaster recovery. Does the provider have a CSIRT team? This is a team for responding to incident. What are the notification policies? What is the disaster recovery plan? Data remnants policy and the decommissioning procedure here. Now, quite frankly, let me give you a real story that happened. Samsung cloud depreciation back in November 2021. Now, Samsung gave users less than 2 months notice before terminating Gallery Sync, MiFi's, and the premium storage services for some reason. Users who were unaware of the depreciation risked losing stored data. This incident highlights why long-term viability assessment, data portability guarantees, and adequate depreciation notice periods must be written in contract, specifying before committing organization data to any cloud provider. Now, beyond provider evaluation, organization must understand data sovereignty requirements when data crosses international boundaries in the cloud here. Let's talk about this topic here. Now, data sovereignty and regulatory compliance. Now, this basically refers to country's law and control over data within its jurisdiction. Cross-border data transfer may impose conflicting legal requirements. There is actually no uniform worldwide regulation, but the GDPR, effective in May 25th, 2018, is the strongest data sovereignty regulation to date, affecting any organization that processes the personal data of EU citizens here. Now, there are, of course, legal issues like license, industrial regulation, labor laws, intellectual property, and digital assets within the corporation. What type of applicable law, provisioning of data, sovereignty laws relevant within specific jurisdiction where data resides or transit. The GDPR impact applies externally to any organization collecting EU personal data. There is huge penalties for not compliance. And finally, we have the encryption restriction here. Now, some nations restrict the strength of encryption that can be used within their borders, obviously to facilitate law enforcement access. This creates compliance conflicts where an organization required to use strong encryption under one regulation, like HIPAA, PCI DSS, may be restricted from being so under another jurisdiction's law or other country, basically. Now, you need, as a security professional, to navigate these conflicts by conducting a detailed analysis of applicable laws in every jurisdiction where data resides, transits, or is accessed. Now, we kind of, went through the regulation requirements. Let's examine the enterprise storage technologies used in the cloud environments and their security implication. Now, in section 5, we're going to talk about enterprise storage and data protection. We're going to look at different type of technologies that is being implemented. So at least you will get understanding about the different type of storage used in cloud. Now, for enterprise storage technologies, let's start with the network attached storage. Now, these devices present a storage as a file system accessible over the network using hierarchical storage protocols. The most common protocols are NFS, which stands for Network File System. It was originally developed by the Sun Microsystems and the CIFS, which stands for Common Internet File System / Server Message Block, SMB. Microsoft's implementation, the CIFS / SMB is done for Windows environments. Now, NAS is often referred to as object storage or file-based storage. A very good example here, you have Amazon S3 simple storage service represents the cloud native equivalent of this model. Now, before I move on to the next one, the NAS security consideration include access, control, enforcement through the file sharing protocol. There's encryption of data at rest and in transit. And network segmentation is to isolate storage traffic from general user traffic. Next one, we have the storage area network, which provides block level storage, different than NAS, file-based storage here. Now, the block level storage appears to the client operating system as a locally attached disk. Now, this architecture delivers ultra low latency, critical for database workloads, transaction processing, and other performance sensitive application. Now, when it comes to SAN security, attention is required to zoning, fabric isolation, and encryption at both the transport and the storage layers. Now, the virtual SAN here introduced logical isolation within a physical SAN fabric. From here, instead of physical, here we'll talk about virtual one. This enables multiple independent storage networks to coexist on a shared physical infrastructure. This consolidation improves resource utilization while maintaining security isolation between different organizational units or tenants. Each virtual SAN operates as a fully independent network with its own addressing, routing, and security policies. The last one is the dynamic disk pools. The DDP represent an evolution beyond the traditional rate, distributing data, priority information, and spare capacity across a pool of drives rather than fixed rate groups. The primary advantages are dynamically faster rebuild times, they're saying up to 8 times faster than rate, and better protection against multiple concurrent drive failures. Now, this technology addresses a critical reliability concern over here. Now, for example, critical reliability concern, like in modern storage, as the drive capacity grow, traditional RAID rebuild times have extended to the point where the risk of a second drive failure during rebuild becomes significant. Now, securing enterprise storage requires not only proper technology selection, but also robust encryption and the key lifecycle management practices here. Now, the storage security best practices. Now, enterprise security, storage security controls. There, MK, here you can see there are like 10 controls form the minimum baseline for securing enterprise storage infrastructure. In a security mature organization, each control maps to a corresponding policy, procedure, monitoring mechanism, and auditing also. Now, for example, know your assets. Perform inventory to identify all data and its storage location. Build a security policy which addresses enterprise storage within the corporate security framework. Implement technical controls. Deploy all these technology you're looking at right now. Okay. Harden system. Remove unnecessary services and application from storage infrastructure. Perform proper updates. Use patch management to roll out deployment systematically. Segment the infrastructure by isolating enterprise storage from general network traffic. Now, use encryption. Protect data at rest and in transit with a strong encryption standard. And then here, implement logging and auditing. Track access attempts, failure, and changes. Use change control. Order processes with documentation and rollback plans. Employ port security, limit switch port traffic by MAC address. Implement trunking security here. Now, let me just talk a little bit here, okay, about a few things mentioned at the end. Now, segmentation and port security. The infrastructure segmentation ensures that organization storage systems are not directly accessible from general purpose network segmentation. Trunking security uses MAC address-based filtering to control which devices can communicate through network switches, effectively preventing rogue devices from accessing storage VLAN. Now, for the port security, it limits traffic on individual switch ports to authorized MAC addresses, blocking unauthorized devices from joining storage accessible network segment here. Now, the change management, okay, this is important. There's actually a course about change management. So the change control, all modifications to enterprise storage configuration, such as encryption settings, replication policies, access control list, capacity allocation, should follow a formal change management process with documentation. Again, also approval workflows, testing procedures, and rollback plans. Now, this is particularly important because the storage misconfiguration can result in data exposure, loss, or corruption that may not be immediately apparent. Now, encryption is the cornerstone of a storage data protection, but its effectiveness depends on the key management practices. Let's examine the encryption and the key lifecycle management here. Now, in the encryption configuration and key lifecycle management, let's take a look at the key ownership models. The choice between provider managed keys here, or bring your own key, or hold your own key, represents a fundamental security trade-off. Now, with providers managed encryption, the cloud provider handles all key generation, storage, retention, and destruction. Convenient, but requiring trust that the provider's key management infrastructure is secure against both external attacks and malicious insiders. Now, the other one, bring your own key, okay, gives customers more control by allowing them to generate and manage their own keys, but the provider still has access to the keys for performing encryption operation, meaning a provider side compromise can still expose the keys. Now, the other one, or the last one, hold your own key, offers the highest security. I mean, why? Because customers generate their own keys, they manage their own keys, and they store their own key entirely within their own infrastructure. And the provider never sees the plain text data or keys. Now, however, hold your own key introduce a new thing is what? It's the operational complexity, particularly for key availability and disaster recovery. Now, let's take a look at the key lifecycle states. Now, Microsoft model, it starts here with the creation, key object created on the domain controller, initialization, key attributes are set and configured, full distribution, key available to all domain controllers, active, available for cryptographic operation, inactive, unavailable for some operation, terminated, permanently deleted from all controllers. Okay, so now when it comes to encryption standard, AES encryption is 128 versus 256. This is basically the standard for data at rest protection. Now, before I move on to the next slide, I want to mention something that this is Microsoft model, as you see. Now, there's another key lifecycle management by NIST SP 800-57 Part 2. Now, if you read this, it provides you with comprehensive guidance on the key management, And this is something I strongly recommend that you take a look at it and read it and try to understand the content of it. Now, with the storage and encryption architecture in place, effective cloud operation depend on robust automation, logging, and monitoring capability. So therefore, let us examine those next. Now, in section 6, we're going to talk about cloud operations and monitoring, the automation, orchestration, logging, SIM, SDN, and backup and recovery. Okay. Now, let's start with automation and orchestration. Okay. Now, automation and orchestration or cloud automation removes human intervention from repetitive process, which is great, directly reducing the frequency of configuration errors. This is why. The leading cause of cloud breaches. Now, orchestration coordinate multiple automated tasks across the environment here into coherent workflows here. Now, among that, there are three other things, like, for example, the Puppet, which is basically, it does a great job at automated provisioning and continuous configuration enforcement with a strong, visualization and reporting capability. The Chef specialize in compliance and security management, making it particularly relevant for organization under regulation. The last one here is the most accessible, Ansible. So they use YAML-based playbooks without requiring agent installation, but may not scale as effective, as you want in very large environments. Now, let's take a look at the software-defined networking, SDN. Now, this represents a fundamental architecture shift in networking by separating the control the control plane where forwarding decisions are made from the data where packets are actually forwarded. Now, in a traditional network, each switch independently maintains its forwarding table through the content addressable memory. They call it CAM table. Now, the SDN centralizes this intelligence in a software controller that can dynamically modify forwarding rules across all switches at the same time. Now, the open flow standard here, The opposite provides the controller to infrastructure interface over here. Now, last thing, we have the backup and recovery in the cloud environment. The shift to software-defined infrastructure fundamentally changed the backup strategies. Rather than backing up entire server images, organization back up the infrastructure as a code. Okay? Backup the infrastructure as a code definitions and the critical data those system manages. Okay, so automation operates in the background, but logging and monitoring provide the visibility needed to detect and respond to security incidents. Let's take a look at this part. Now, for cloud logging, monitoring, and SIM, the first one here we have the log management fundamentals. Effective logging in the cloud environments require a strategic approach. You need to identify which logs carry security value, collect them consistently, store them securely with appropriate retention periods, and analyze them for indicators of compromise. Now, the CIS critical security controls version 8, okay, now devotes an entire controller to audit log management, recognizing that logs are the forensics foundation for detecting breaches, investigating incidents, and demonstrating compliance. Now, without centralized logging, okay, the attacker can establish resistance in the cloud environment and operate undetected for extended period. Okay. Now, key logging consideration. Now, the first thing here is that we have normalization and correlation. Now, think about it this way. Normalization describing the data into a specific field. Correlation connecting events into sequences. Basically, the correlation would be done when you collect data from a different location here. Now, we know that the logs are considered as a raw logs. They're coming from different devices using different formats like for timestamps and field structure. So the normalization, okay, break down logs into standardized field. Okay, that's the prerequisite for meaningful analysis. Now, once normalized, the correlation here engine can connect events across multiple data sources to identify attack patterns that would be invisible when examining any single log in isolation. Now, so that's a typical thing that happened in a SIM system, and that's where we're coming here into the SIM solution. SIM solution, like for example, IBM QRadar, they aggregate data, they do normalization, correlation, and then what they do next, they send you the alert, okay, which is a proactive notification, and the data is stored in a secure manner. For what? Well, for forensics purposes, obviously. SIM solutions, the security information and event management tools, okay, consume logs from across in the environment. Cloud platforms, for example, on-premises infrastructure, application, endpoints, and network devices. And then the SIM system will apply behavioral analytics to detect anomalies. The baseline establishment period, according to some software, okay, for the baseline establishment between like 2 to 4 weeks, okay, which is critical. Now, the SIM must learn normal patterns before it can effectively identify deviation. Now, leading platform each have their own strength. For example, like Splunk for log search and customer dashboarding. Okay, IBM QRadar, they have also excellent dashboard. I work with these at and they are excellent tools. You got the Rapid 7 inside IDR for cloud native environments. You got the Logarithm. This is for smaller enterprises. And the last one for user and entity behavior analytics here. Now, we got also the open source logging here. Now, ELK stack, is the most common open source centralized logging solution. Logging infrastructure tools include syslog, syslog-ng, and other collectors that build evidence trails for incident analysis. Additional artifacts like network flows, file metadata, and system metadata support deeper analysis. Now, monitoring best practices. Before you do monitoring, okay, it's very important to define the critical metrics and events. Monitor all cloud infrastructure from one platform. Automate monitoring tasks. Track end user experience. Test for cloud failure scenarios. Monitor services and cost. Compliance monitoring through tools like Puppet or SolarWinds enable automated audit preparation. Now, this complete section 4 through 6, okay, the one we discussed about the security. Now, before we proceed to the last part, while operational monitoring in place, let us turn to the security of collaboration and communication tool that organizations increasingly rely upon in the cloud environment in part 3.